Alright, so I just did on the Causeway here in New Orleans, I just did the Northbound. So here's all the points, 2,000 points, give or take. So if I measure there, I get 23.61 miles, or 6061. Okay. Save that. Say color red. Red. So here's my drawing. That's the perfect circle. Go with the globe, and so the prime meridian is the one I'm after. So these measurements here is 6378137, and then the 6356752. So the semi and the major, or the major minor. So that's what this is right here, prime meridian, and to the right hand corner right here is the minor and major. So I got 6378137. Same thing. Then for the minor, I made it 6356752 and 6356752. Okay, that's the minor. And that's the minor. Okay. And that's what that line is. These lines are based off of. Okay. Bam. And the origin, which I go ID, and I pick that point, 0, 0, 0. Okay, so that's 0, 0, 0, the origin point. Now, when I extend these down, they do not hit to the center of the Earth. They hit right here, which is displayed just like this. They don't hit here in the middle. So they hit right there. And Jesse would have to, I think that's pretty much the base center, maybe. Okay, so now this one hit on the south end, hit perfectly. This one was off a little bit. The reason for that is because, for instance, like when we go out on topo, documents, cat, okay, I did this with CD, with robot. Okay, so we use 4 decimal places on our points, and it's pretty important. So Jesse gave me 2, which that's why I was off. And I'll show you. I mean, I wasn't off a lot. Northbound. Okay, so this one on 25, he gave me 3. That's why that one hit. The this one right here, how it hit that line. You can see it. Okay, pretty good. I'm satisfied. Now for the last one at the end, I did this to get the delta. So I added these 2 points so I could get my straight line, plumb line. But on this one, he gave me, that one's 2 decimal places. That one's 3. But I don't know if that, if I had an extra number there, if that would have made a difference. I don't know. So some of them have 3 and some of them have 2. I would prefer 4, but that's just how we do it. So 4 decimal places. I guess I can show that there's no trickery. And these points come in where they're on the globe. Almost afraid to rotate it, which I have to. So I'm going to delete these points or get rid of them with my prospector here. So I'll delete and say yes. Now they're gone. Now I just have nothing. Okay. Now I go import. Whoops. I got it. Import survey data. Next. And so then I pick Northbound, because that's the one I did. I think I need a better laptop to actually do this out. So we're just doing the Northbound. So I go open. And then I come down here, PNEZD, coming to the limit. And then I hit next. Now I got my 3D line. 3D, how I made my 3D lines is we have point codes. So I made it into a break line first. So it drew a figure. See that process line during it. It creates a figure. So some codes in surveying will have a figure and some of them don't. Like, so the PNT is just a point, and so it doesn't draw a figure, which is the shape of whatever you're shaping, you know. So first I changed the code to BKL, and then I exploded it, and it turns it into a 3D polyline. And then I deleted the points, and then I turned them into PNT, and then that's how I got my 3D polyline instead of just connecting all the dots, because that's way 2,000. That's 2,000 clicks. So that's how I did that. Anyway, so I go next or finished, and then it's importing 2,109 points. All right, so they're in there. All right. So once they're in there, so that's why I need that straight line right here that I added that point, so I have a plumb line. If I could draw, if I just have these series of lines, then I can't draw. I cannot draw this line right here with one point. So that's why I need a plumb line. So I created another one. So, which that's not what we wanted to do, but I just did it anyways, because Jesse wants to see that guy right there, my solid. So here's my 3D polyline with all those points. That's just a copy. But I also have it here too. So you draw a line straight down. That's what I do to the equator. So that's what that line is. And then I set I can get rid of that. Well, maybe not. Get rid of well, so then I set my 3-point UCS. So I go in, NEA for nearest, and then a node NEA there, and then it sets me in that plane, and then I can draw that line. Then I extend it. Well, first I got to rotate, like I just copy that and rotate it, draw that down, I rotate it, and then I get it to there, then I extend it. So like if I go, so that's how I do that. Let me, yes, I can show chord. Okay, so we'll measure, so based on that, it will give you the latitude and longitude, right? So we'll do that real quick. Okay, so I set, so that's the south, that's the north. Okay, so NEA, to endpoint to there, and NEA to there. Now I can measure the angle of the latitude. So I got 30, 1, and we'll see what this is. So it's, you can see right here, it's 3001.23 north latitude. And I got 31.23. Okay, now we'll go from the prime meridian, so there to that line, and measure that. It's off, I already know it's off a little bit. So, for the longitude, and it gives me 90.09. And so I almost get, 52 and then 60, so it's 90, almost 09. Pretty close. The other one, the latitude was perfect. Now, we'll measure the distance. And so I need to know the angle between those 2 points. So I do my UCS 3-point from there. And I don't go to that point because that won't work. So I go to the center and then I go back up to the other side, to the north end node. And then I can measure it. And I'm going to go to gem style. So I got .34. I'm going to get rid of it. We know what the distance is. 23.6 or 61 miles. So I get my curve calculator. And I want to know the radius of the Earth. And I put that in for the radius, for meters. Okay, now it wants to know the chord. That's basically what this is, the chord. So I have a line already in here. I can get to it. So my line, the distance from the north and south is that. This number right here. So change that, radius, chord distance, bam. And then it gives me the delta, which is 0.3417. And it'll give me the arc length too. It's very important. Okay, so we already know this. I'm just showing again. .34. Okay, so this arc length is that one right there. So I come over here to convert, and I need meters to miles. Paste, and then I get 23.6, and that's what we measured. So if I 23.6, so if I come over here, I'll even show you again. I did that on Google. So there's my line. I can so let me close this. So from point A to point B, or A to B, whatever. So that distance is per meters, miles. Hey, same thing. 23.60. 61. The one around. So we can verify that these coordinates that Jesse got are good. Because I just showed it on Google Earth. I just showed it 3 different ways. So now so these, let's see. There's my 3D polyline. And you see like this vertex is at each point with that elevation. Alright. So I'm gonna freeze this layer. I don't need that. And the chord line, don't need that. But I do need the 3D polyline, and that's just a copy. So if I go to my side view of it, so I built this road as a 30-foot or 31-foot road with a crown. So there's a crown there. It tapers down. This is like a side view, kind of. So I basically got 1, 2, 3, 4, 5. 5 humps. And these are the big ones that everybody's, whoa, that doesn't look right. Right here. I like this picture. That's beautiful. So that hump there is probably this first one. And that second one here. He probably couldn't shoot because of the window. He couldn't shoot this way. So I mined right here. I didn't do this one. Mined right here. But it's a pain in the ass to get that view. Come on. Sure. I just have to. But when you rotate it, it does exactly what his picture is showing. That's just my 3D polyline. I could hit render here. Realistic, but and that's 30 foot, 31 feet wide road. It's pretty typical. Guess I could have drawn that line back. Record. Okay. I'm scared to move it. I don't want to waste too much time because it just. So the more I twist it, which I'm not quite at his angle, the steeper these bad boys get. I'm scared to even. I don't want to ruin my demonstration here, but I can try to move. That's probably too much. See how they get higher. You know, I'm not exactly at his view, but you get the concept. Okay. Actually, that's the beginning. I can tweak with this all day long. Probably not get the right view. But I mean, these dots, I don't know. I I don't know. I like the program because it doesn't use. You can uh, move it around probably a lot easier and manipulate it versus with mine. I need a more horses in my computer. Well, I'm doing this and it's doing it the opposite way, so it's not easy. So you get the concept anyways. There's no trickery done with this. So if there was this antenna right here would be warped. It's straight up and down. So in this, like this light pole, straight up and down. All these are straight up and down. So there's, it's showing the curve. I like this picture though. It's awesome. And I'll put it into After Effects, because I got a video of it driving. So I'll open up my Adobe After Effects and add this video to it. So it's already at 40 minutes, and